All right, so here's your homework to do with sector area and length of arc, or arc length. So for these, we just have some simple formulas we're going to use. So let's make sure we use them correctly. So in this question, you have an arc and you have an angle. So the radius of a circle, so we have a circle, and the radius of the circle is 10 millimeters, and the angle that's intercepted for is 3 pi over 4. And you're asked to find the length of an arc. So we need to know the formula. Let's just get down to that. So the formula, and usually the letter we use for arc length is S. We don't use A because that usually represents area. And you take the radius times the angle in radians. So in this case, it's just 10 times 3 pi over 4. We're going to round to the nearest tenth, so we are going to go diamond enter when we put it in our calculator, and you get 23.6. That's as easy as it is. So I want to know arc length. So the radius is 17.5. The angle in radians is 8 pi over 7. Use your calculator, and then go diamond enter, and you get 62.8. Again, the radius and the angle in radians. Oops. Go diamond enter when you put that in, and you get 1. When you round it, 5 pi over 8 and 18. Go diamond enter, and you get 35.3. Here we have the radius, 0.9, but this is in degrees. So in our calculator, we need to change it to radians. So when you type it in your calculator, just go pi over 180, and then go, when you type it in, and then go diamond enter, and now it's in radians and not degrees in one step, and you would get 5. Number 6. Again, the radius is 4.5. Again, 100 is in degrees, so I'm going to go pi over 180 right away, and then use my calculator, and you get 7.9. You can press pause if you want to try to use your calculator and see if it matches. Again, arc length 6.6, 240, go pi over 180, diamond enter, and you get 27.6. And lastly, you have the radius, 2.2. Again, 45 in radians. You go 45 pi over 180. Now it's in radians. And then the answer is 1.7. So again, simple formula for arc length is the radius times the angle that's been used to make the arc. And angle has to be in radians. All right, 9. An intercepted arc has a length of 19 yards, the radius of 4. Find the measure of the angle in radians and in degrees. So we have a formula. What do we know is the arc length is 19. We know the radius is 4. What we don't know is the angle. So to get the angle by itself, it is 19 divided by 4, and that's in radians. You could also write that as a decimal, but it doesn't need to be. And then to change that to degrees, you go 180 divided by pi. So that's in radians. Times 180 over pi, and it'd be 272.2 degrees. Number 10, the end of a minute hand on the clock is 5.5 inches. How far will the minute hand travel over 3 full days? Well, if you think of a clock, if you like, this minute hand is really the radius. So when it says the minute hand is that, it's really the radius that's 5.5 inches long. And how far does it travel around the clock? We have to understand what angle that would be. Well, if it travels all the way around, obviously, that's like the full circumference of the circle. So if you wanted to, in radians, that would be 2 pi. But that's only one time around. And so if it's 3 full days, it would be 3. That would be the angle all the way. It would be 3 times that. And if you put that in your calculator, you get and you go diamond enter, it's 207.3 inches. All right. How about sector area? What's the formula there? A little bit more, but not much. 1/2, and it's r squared theta. So the angle, again, has to be in radians. So we go 1/2, and in your calculator, it's probably just as well to practice 0.5. The radius here is 19, and you square it, and the angle is 88 degrees. So we need to go pi over 180, and that's it. Use your calculator, and you get 277.2 feet, and it's squared because it's area. Let's try that again, the shaded area. So if I want to find the whole shaded area, that's called a sector. The formula is 1/2. It's the radius, which is 11 squared, times the angle in radians. And then use your calculator, diamond enter, and you get 274.5 miles squared. Number 13. So again, the formula, make sure you square the radius, and 7 pi over 12 is in radians, so that's good. And then use your calculator and you get 35.2 kilometers squared. Number 14, 1/2. The radius is 21. No, what is the radius here? Sorry, 7.1. 7.1 squared, and again the angle's in radians, we don't need to change it. When you type it in, go diamond enter at the end, and you go 519.5 meters squared because it's area. Two more like that. So again, practice the formula and you'll remember it. So the radius squared times the angle in radians. You have to go pi over 180. If it's in degrees, use your calculator, type it in, diamond enter, and you get about 38 yards squared. And then the last one here, again, practice the formula. The radius times the angle in radians. So it's already in radians, so I don't need to change it. Type it in, diamond enter, and you get 519.5 meters squared. All right, let's do a couple quick stories. The sector of a circle has a central angle of 144 and an area of 70.7. Find the radius. So the formula is area equals 1/2 r squared theta. In the question, it tells you that the angle is 144 and the area is 70.7. And what I'm looking for is the radius. So when I plug in the angle, make sure you write pi over 180 to put it in radians. The area is 70.7, and then I just need to solve for r. So just go one step at a time. So we can combine these together and simplify it down. So 144 over 180, to make it a little bit easier, is 4 pi over 5. Then 1/2 and 4 pi, 2 goes into 4 twice, so it's really 2 pi over 5. Now we're going to do the reciprocal to get r squared by itself. So we're going to go 5 pi over 2. Try that again, sorry. The reciprocal is 5 over 2 pi times the 70.7. And then the last step to do that is we're going to take the square root of that to get r by itself. So that's what you're going to type in the calculator. And you should get 7.5 meters. A circle with a radius of 15, a sector area of 609. Find the measure of the angle in both radians and degrees. So the formula, 1/2 r squared theta. It says the radius is 15. It says the area is 609, and I'm looking for the angle. So I'm going to simplify it, and I'm going to solve it. So $15 squared, and then take half of it, is 112.5. Divide. And in radians, the answer is 406 over 75. And if you want that in degrees, you'd have to go 180 over pi, and that'd be the same as about 310 degrees. So 310 degrees, that's the one in radians. Last one here, a wall clock is equally divided into 12 sections. Maybe there's another page after this. If the clock reads 8 o'clock and has a diameter of 12.5, find the area of the smallest sector formed by the minute and hour hand. So if the clock reads, the wall clock is equally divided into 12 sections. If the clock reads 8 o'clock, if the clock reads 8 o'clock and has a diameter of 12.5, so that means the radius would be half of that. That would be 6.25. So then you have to look at what's the angle made when it reads 8 o'clock. So you have the big and you have the small. So that would be this area in here. Now, let's understand what that angle would be at 8 o'clock. So we have 12, 11, 10, 9, 8. So it might be helpful to know the entire circle, or the entire clock, is 360 degrees. If I divide it by 12, that means each hour between each number, 12 and 1, 1 and 2, and so on, would be 30 degrees. Now, I know that in the, let's just see what they're doing. Anyways, so 360 divided by 12, that means every between 12 and 1, 1 and 2, 2 and 3, and so on is 30 degrees. 30, 30, 30, yeah. And that at 8 o'clock, what would the angle be between the 8 and the 12? And I don't get quite why the answer key says it's 2 pi over 3. Maybe you can help me out with that in terms, or pi over 6 is the angle in terms of it. Because the angle I see made here would be 1, 2, 3, 4, would be 120 degrees, that angle. So at 8 o'clock, the angle between the minute hand and the hour hand should be 120. It's beyond 90, right? Add 30 all the way around. So I'm going to use that. So find the area of the smallest sector. I'm going to go 1/2 6.25 squared. And then the angle in radians would be pi over 180, and then use your calculator. So I'm going to do that now. So I get 40.9062. Which is kind of the answer that's there. I guess when they said section, that's what they mean when I look at it. So one little section is 30 degrees. Then times 4, it would be 120. So I guess it all worked out. So it's 40.9 inches squared. Maybe I didn't quite understand the answer key and how it was written. All right, turn the page. Is this it? Is this it? Is this it? This is it. So no more homework. Mr. G Math, over and out.